Rigid non-metallic conduit, often abbreviated RNMC, can indeed be used for feeding a main breaker box and for the return trip to a distribution panel, even when using a cable tray. The National Electrical Code, or NEC, provides specific guidelines for its approved usage. Let's delve into the relevant sections of the NEC to clarify the rules governing such installations. Firstly, Section 358.1 of the NEC permits the use of RNMC for both underground and above-ground applications. This is a fundamental allowance, establishing RNMC as a versatile option for various electrical raceway needs. This section allows the electrician or installer to use the rigid non-metallic conduit for both underground or above ground, making it a versatile option to consider. Secondly, Section 358.1b allows RNMC to safeguard conductors as they enter a building from service equipment or other door enclosures. This is particularly useful for protecting wiring from environmental factors and physical damage. Protecting the wire or cabling is very important, hence the use of rigid non-metallic conduit, because it is a very durable material, especially compared to other types of conduit and wiring options. Thirdly, Section 358.12 mandates that RNMC must be supported within 12 inches of any termination point. This encompasses terminations at panel boards, ensuring that the conduit is securely fastened to prevent stress and maintain electrical integrity. This is an important consideration because without supports within 12 inches of any termination point, this could cause stress on the electrical system due to damage. Now, let's consider the specific scenario described, where RNMC feeds the main breaker box from a cable tray and then returns to the distribution panel. This configuration falls within the permissible uses outlined in the NEC, provided that the support requirements are met. In the scenario described, it is important to note that the conduit is indeed supported within 12 inches of the termination points at both the main breaker box and the distribution panel. This adherence to the NEC standard is crucial for a safe and compliant installation. The fact that the installation was approved by the authority having jurisdiction, known as the AHJ, is also significant. This approval signifies that the installation complies with all applicable local and national code requirements. The AHJ approval serves as an independent verification of the installation's safety and code compliance. Now, let's address the question of why a bushing might not be required at the bottom of the panel in this particular installation. A bushing is not required at the bottom of the panel in this case because the RNMC is flexible and conforms to the contours of the panel. Bushings are primarily used to shield conductors from sharp edges, preventing damage to the insulation. However, when RNMC is used, its smooth, non-metallic surface eliminates the need for a bushing in many cases. To summarize, let's review the key points. Rigid non-metallic conduits can be used for both the feed and return pass between a main breaker box and a distribution panel, including installations involving cable trays. The NEC permits this application under Section 358.1 and Section 358.1b. Proper support within 12 inches of termination points, as per Section 358.12a, is essential. The absence of a bushing at the panel bottom is acceptable if the RNMC is flexible and conforms to the panel shape, eliminating sharp edges. Finally, AHJ approval confirms code compliance. When working with electrical installations, it is always crucial to consult the latest edition of the National Electrical Code and any applicable local codes. These codes provide detailed guidelines for safe and compliant installations. Additionally, it is always advisable to consult with a licensed electrician or qualified electrical inspector to ensure that your installation meets all requirements. Understanding the nuances of the NEC, such as when RNMC can be used for both supply and return pass, and when bushings are necessary, is essential for anyone involved in electrical work. Proper adherence to these codes ensures not only compliance but, more importantly, the safety of the electrical system and the people who interact with it. Let's explore further some additional considerations for using rigid non-metallic conduit in similar installations. Firstly, conductor fill. It is very important to ensure that the number and size of conductors within the RNMC do not exceed the allowable fill percentage as specified in the NEC. Overfilled conduits can lead to overheating and potential damage to the conductors. The NEC provides tables that specify the maximum number of conductors permitted based on conduit size and conductor type. These tables must be consulted to ensure compliance with fill requirements. Secondly, temperature considerations. Our NMC is rated for specific temperature ranges. It is important to select RNMC that is suitable for the environmental conditions of the installation. Exposure to extreme temperatures, whether high or low, can affect the conduit's integrity and performance. The manufacturer's specifications should be reviewed to determine the appropriate temperature rating for the application. Thirdly, expansion and contraction. RNMC, like other materials, expands and contracts with temperature changes. In long runs of conduit, expansion fittings may be necessary to accommodate this movement and prevent stress on the conduit and its connections. The NEC provides guidelines for determining when expansion fittings are required based on conduit length and temperature variation. Fourthly, securing and supporting. While Section 358.12 requires support within 12 inches of terminations, additional supports may be necessary along the length of the conduit run. The NEC specifies the maximum spacing between supports based on conduit size. Proper securing and supporting of the conduit ensures that it remains in place and protects the conductors from physical damage. Fifthly, grounding. Although RNMC is non-metallic and does not serve as a grounding conductor, it is essential to ensure that the electrical system is properly grounded through other means. A separate grounding conductor must be installed within the conduit to provide a path for fault current back to the source. The size of the grounding conductor must be determined in accordance with the NEC. Sixthly, protection from physical damage. While RNMC is durable, it is still susceptible to physical damage, especially in exposed locations. Where the conduit is subject to impact or abrasion, additional protection may be necessary, such as installing it in a more protected location or using a heavier duty conduit. Seventhly, exposure to chemicals. RNMC can be affected by certain chemicals. It is crucial to select RNMC that is compatible with the chemicals present in the environment. The manufacturer's specifications should be consulted to determine the chemical resistance of the conduit. Eighthly, sunlight resistance. Some types of RNMC are not resistant to ultraviolet light from the sun. Prolonged exposure to sunlight can cause the conduit to degrade and become brittle. If the conduit is installed in an area exposed to direct sunlight, sunlight-resistant RNMC should be used. Ninthly, fittings and connectors. It is important to use fittings and connectors that are specifically designed for use with RNMC. These fittings ensure secure and watertight connection between the conduit and other components of the electrical system. Fittings should be installed in accordance with the manufacturer's instructions. Tenthly, inspection. After the installation is complete, it should be inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and standards. The inspection should include a visual examination of the conduit, fittings, and supports, as well as electrical testing to verify the integrity of the system. By considering these additional factors, you can ensure that your RNMC installation is not only compliant with the NEC but also safe, reliable, and long-lasting. Always prioritize safety and consult with qualified professionals when working with electrical systems.